Hi guys, so today we're going to look at the first time we're going to graph quadratic equations. So we know that quadratic polynomials are always of the form y is equal to ax squared plus bx plus c. Okay? The key term there is the x squared. That's what makes it a quadratic polynomial, because it's got that squared function, or a quad. Okay, so this can be graphed on the Cartesian plane in the form of a parabola. So this is a really key concept that we're going to be going over for the next couple of weeks. So the best way to learn about parabolas is to actually start graphing some simplest parabolas. So the simplest polynomial is of the form y is equal to x squared, where there's no extra coefficients or extra terms in the equation. So let's graph it. So I want you to take a moment now to pause this video and go through filling out this table of values. So when x is equal to -3, -2, -1, what is y equal to using this equation? Okay, so when x is equal to -3, y is equal to -3 all squared, which is equal to +9. Y is equal to, when x is equal to -2, y would be equal to 4, because doing y is equal to -2 all squared, which gives you a positive number. -1 squared is just 1. 0 squared is obviously remains 0. 1, 4, 9. So you can see it's got that symmetry about the origin here. So if we actually plot that on the graph, so when x is equal to -3, y is equal to 9 there. When x is equal to -2, y has dropped down to about 4. When x is equal to -1, y has dropped down to 1. Then 0 at the point, this point here, and then it goes back up. When x is equal to 1, 4, 9. So you can imagine as it keeps going up, it's just going to continue to get steeper and steeper and increasing in value, and so move in either direction. So if you connect those dots up, obviously better than this, so in a smooth kind of motion, have a look in your textbooks, exercise 3D, for a more accurate picture there. You get this kind of smiley face or curve, which is symmetrical about the x-axis. Okay, so let's look at a couple of different iterations of this. So once you go through now, let's have a look at y is equal to -x squared. So when x is equal to -3, y would be equal to negative, that negative's there, so that changes it, -3 squared. So y would be equal to -9, because that -3 squared is +9, but you've got that negative out the front. So now you can see that's -9. So when x is equal to -2, y would be equal to -4, following that same formula there. -1, y would equal to -1. When x is equal to 0, y is still equal to 0. And then, when x becomes positive, 1 squared is 1, but it's, remember this negative out the front, so it's -1 again. -4, -9. So if we were to graph, so if we label our y is equal to x squared here, we'd go down here, and if we were to graph this again, it would be the inverse of what we had before. So it's tapering off, getting lower there, and then getting the larger values back out here. So got to be clear there that that's 1. So that's cutting the x-axis, or touching the x-axis, doesn't go through it at the origin. So when it's -x squared, y will never be positive when y is equal to -x squared. Whereas when y is equal to x squared, y can only be positive. There's no value for x where y could become negative because of that squared number there. Okay, so we're going to go through this a lot more in class. I just wanted to get this preparatory video so you guys are ready for class.